When a human muscle is pushed to its absolute limit, the environment inside the cell behaves like a biological engine running at maximum capacity. Every microscopic fiber fires and contracts to keep the heavy body moving forward. To meet this urgent demand for power, the muscle cells rapidly break down their stored sugars. This chemical process, known as glycolysis, provides a massive burst of short-term energy to sustain workload. But this rapid energy production comes with a metabolic cost. As sugars break down, a sour byproduct called lactate begins to pool and accumulate directly within the muscle fibers, causing a familiar, heavy burning sensation. Scientists previously categorized this acidic accumulation as useless cellular trash, responsible for fatigue and soreness. Modern research, however, reveals a highly efficient system at work. Your body does not throw this acidic byproduct away. Instead, it recognizes these lactate molecules as a concentrated, untapped energy reserve ready to be reclaimed. To relieve the pressure on the working tissues, the muscle cells expel the excess lactate directly out into the surrounding bloodstream. The rushing blood acts as a systemic conveyor belt. It catches these circulating molecules, carries them away from your exhausted limbs, and sweeps them steadily downward toward your digestive tract. During intense physical stress, your tight intestinal barrier opens temporary gaps, allowing circulating lactate to drop directly into the gut lumen. On the other side, a sudden wave of acidic material arrives, and the microscopic residents must immediately address this influx of chemical exhaust. By shifting this chemical burden across the intestinal wall, your biology successfully prevents a metabolic traffic jam in your legs, relying instead on the gut to handle the overflow. Deep inside the gut lumen, a specialized microscopic recycling center goes to work. This environment is home to a unique bacterial helper known as Veillonella atypica. While most bacteria in the digestive system prefer to feed on dietary sugars and fibers, this specific microbe has evolved a different appetite. It ignores normal food and actively hunts down the incoming muscle lactate. The bacterium pulls the captured lactate into an internal assembly line. This methylmalonyl-CoA pathway systematically dismantles the molecule to extract its energy. When complete, it emerges completely reshaped. The acidic exhaust is now a highly stable short-chain fatty acid called propionate. This microscopic digestion neutralizes the dangerous acidity within the gut, while simultaneously turning cellular exhaust into high-grade metabolic fuel. The newly forged propionate does not stay in the digestive tract. It crosses back into the bloodstream, bypasses the liver, and travels straight back to the active leg muscles that are still working hard. When these tiny fat molecules arrive at the muscle cells, they locate and bind to specialized receptors that act like biological antennas on the outer surface of the cell. This physical connection triggers an immediate internal chain reaction. The signal travels deep inside the muscle cell and activates an essential energy-sensing master switch known as AMPK. Once flipped on, this master switch monitors the local energy levels and commands the muscle to physically construct new power plants. These microscopic structures, called mitochondria, rapidly form to handle the body's future energy demands. With an increased number of mitochondria burning energy within the muscle, an athlete can sustain high-intensity sprinting for longer periods, delaying exhaustion right when the body needs power most. This automated internal engine requires constant maintenance. To ensure this specialized microscopic workforce remains alive and ready to multiply, the human host must provide the right daily nourishment. The foundation of a healthy gut ecosystem relies on prebiotics. These are complex, non-digestible plant fibers found in foods like oats, bananas, and onions, which travel untouched through the stomach to serve as raw material for the bacterial community. Delivering a consistent daily influx of diverse plant fibers ensures that the helpful recycling microbes maintain high population levels. A well-fed ecosystem is always standing by, prepared for the next physical stress event. Peak human athletic endurance arises from a continuous energy recycling loop shared between human biology and its microscopic partners.